In this lesson, we will discuss how the key concepts of time value of money can be applied to various accounting or finance topics. Our initial topic in this lesson is simple versus compound interest. Simple interest is basically the initial investment times the interest rate times the time period. An example of this would be if we have $100 that we invest for 1 year at an annual interest rate of 10%, that would be worth $110 at the end of the first year. Pretty basic, right? Next, let's discuss compounded, which is quite honestly the best of all. This is what we want in our valued investments. Compound interest is our initial investment plus the prior interest times the interest rate times the period. So example of this would be if we have $100 invested for 3 years at an annual interest rate of 10%, compounded annually, what would it be worth? Well, let's review this slide calculation together. Year 1, this looks very similar, right? This is what we just saw in the simple interest example. At the end of the first year, it's worth $110. Now the compounding takes effect in years 2 and 3. So at the end of year 2, we take the 110, the original principal, plus the interest we earned in year 1, times the 10% interest rate, and now we grow that to $121 at the end of the second year. At the end of the third year, you'll see you take that $121, again at the 10% interest rate, and now you've built that up to $133.10 at the end of the third year. Much better when you're earning money on top of your interest. Our next topic is present versus future value. First of all, let's talk about future value. The future value is the amount of money that $1 will grow to in some future period. To calculate future value, as you see here in the formula, it's investment, represented by I, times 1 plus little I to the nth power, where the little I is the interest rate and the n is the number of periods. Let's go through an example to kind of make this make a little bit more sense. So in this example, how much would I have to save after 3 years if I invest $100 for 3 years at an annual compounded rate of 10%? For the previous example, as well as for using your future value tables, which can be found online or in our textbook, basically take $100 times 1.331, which is the future value factor, get you that $133.10 that we saw in that prior example. Next, let's look at present value. That's the current value of money to be received in the future. So for example, how much do I need to invest today in a savings account to achieve my retirement goal of $133.10? I know, not a very lofty goal, but we've got to start somewhere. When I turn 60 years old in 3 years, if the compound interest rate is 10%. Well, per the prior example, as well as using your present value tables, which you can find online, you take the 133.10 times the present value factor, as you see here, 0.75131. That gets you to $100. It's what you started with, right? Our next topic is going to be annuities. A little bit more complicated. We talk about ordinary annuities versus annuity due. So what are annuities? Annuities are a series of cash receipts or payments that are equal in amount every period. There's 2 types we have to look at. An ordinary annuity has kind of a bland name, but it basically means cash flows occur at the end of each period, key point being end of the period. Then we have the second type, which is annuity due, where the cash flows occur at the beginning of the period. So next, let's look at an ordinary annuity example. Let's say, how much would I need to accumulate for a new car if I invest $10,000 at the end of each of the next 3 years in a savings account at an annual compounded interest rate of 10%. I know your first question is, where do I get 10% in today's world? Hard to do, but let's say we invested very healthily and got that return. By using our future value of an annuity table found online, you could take your initial amount that you're putting in for each of the 3 years, $10,000, times the future value of annuity factor of 3.31, you'll come up with $33,100. Sounds like a pretty nice vehicle for the old professor, right? Next, let's talk about annuity due. How much would I accumulate for this new car if I invest $10,000 at the beginning, not the end, but the beginning of each of the next 3 years in a savings account at that annual compounded rate of 10%? Well, by using the future value of an annuity due table found online, you take your $10,000 times that FVAD factor of 3.641, and you get $36,410. Now this sounds like an even nicer vehicle. I'm kind of liking this idea. Let's stop here and recap what's just happened. Keep in mind the future value of an ordinary annuity when I put it in at the end of the year was $33,100. The future value of an annuity due when I invested that $10,000 at the beginning of the year grew to $36,410. Quite a difference, right? Well, as you'll see here, what you just saw, quite honestly, is the power of the time value of money. The key takeaway from this is the earlier that you put money away for your retirement, whether it's be in a 401k or a 403b or other retirement vehicle, the more money you're going to have to enjoy in your retirement. Now I bet you're very glad you took this course.